Alright guys, let's solve problem number 2 from the sample midterm. That's part A. You're given 3 functions actually, not 2, and you're asked to find the sum of a couple of them or the dot product or the quotient, and then find the domains. I think this is one of the easier tasks on the midterm, so you should definitely, try to just make sure you understand how to find the domains when there's interacting functions, because I think these are decently easy points, right? So how do you do it? Here's the general algorithm that I personally follow when solving these. The first step is to just find the domains of the separate functions, right? So I'm not going to get right into the summation or anything. I'm just going to find the domain of f, the domain of g, and the domain of h, or however many functions I have. And then I'm going to start working on the composite functions. So you just need to remember a couple of rules here. They actually make sense. So if you have summation of functions or dot product or subtraction, it's basically the same thing. So the domain of the composite thing, it could be f plus g or h, doesn't really matter. Could be f minus g, could be domain of f dot product g. And again, you could have all 3 functions. It doesn't really matter what combination it is, but it's always the same. It's always the same formula. It's the domain of the first function intersected with the domain of the second function. And for example, if we were to have domain of f plus g plus h, then you would just intersect it with the domain of h as well, right? It's the same practice. So that's the way you find it. And you're done, basically. Now, for the quotients, it's slightly different. There is an extra thing that you need to find. So for the quotient, for example, f over g, you start the same way. You have the intersection of the two, but from that intersection, you need to subtract the point or points where g, or whatever the function in the denominator is, equals 0. Okay, so nearly identical to the previous. That part's the same, but you subtract from it the points where g, or whatever the function in the denominator is 0. And if you think about it, it actually makes sense, right? Because we cannot divide by 0. So if g is 0, this is not going to be in the domain. We need to subtract this from the domain. Okay? That's the only difference between the two. So that's the general algorithm, and now I guess we can just solve. I'll actually move this to another page in case we need to refer to it, but I don't want it here because it's a bit annoying to have it here. Okay. All right, so starting with the first step, we're just going to calculate the separate domains of the functions, right? So domain of f. There are actually 2 main cases that you might have when dealing with domains. One is you might have a radical, and the other one is you might have a fraction. With any other type of regular numbers, you don't really have any specific cases for the domain. You don't have what to remove from the domain usually. But fractions and radicals are the 2 main types you see in these problems. So how do you work it out? For radicals, the first task you have is to see the number of the radical. Which root is it? So if it's, how if there's no explicit root, it's just second root. So if it's second or fourth or sixth or eighth or any even root, then you need to make sure that the thing inside of the root is greater than or equal to 0. Okay? So let me just write it down on that page. Somewhere here. For even radicals or roots, it's just the same. Radical is the sign itself, root is the function, but it's basically the same thing. You need to make sure the expression inside the radical is greater than or equal to 0. That's the rule, okay? So you take whatever expression you have inside or under the radical, and you make sure it's greater than or equal to 0. Now, what if the radical is odd? Then you're lucky, because for odd radicals, we have no excluded values from the domain. So the domain is just everything, or R, as you know the notation, right? So odd radicals are really cool, but on exams you're more likely to have even radicals because it's more complicated and you need to show that you can do more complicated things. Okay, anyway, that was the first rule. And then the second case is that you might have a fraction, and for fractions you just need to make sure that the denominator is different from 0, because we cannot divide by 0, right? So for fractions, you need to make sure that denominator should be different from 0. Okay, these are the two main things. Now, in some more complicated problems, you might have them combined, but it's still the same thing. You just need to make sure that the fractions don't have 0 in the denominator, and the radicals have a value greater than or equal to 0 inside of them. Okay, that's the thing. And that's only for even radicals. Oops, even radicals. Okay, so let's move on. Domain of f. We have an even radical, therefore we need to make sure that the expression inside of it is greater than or equal to 0, right? So 4 minus x needs to be greater than or equal to 0. I could move the 4 to the other side with the opposite sign, right? So minus x greater than or equal to minus 4. And in order for me to just get the value, or like the range of x, I need to multiply both sides by minus 1, okay? But when you're dealing with inequalities and you're multiplying by a negative number, it's super important to remember that the sign changes the direction. So because I'm multiplying, by the way, this is not x, this was meant to be multiplication. I don't know what sign to use. But because I'm multiplying by minus 1, I will also change the direction of the sign. So now it will be less than or equal to 4, okay? That's the thing to remember. Okay, that's the domain of f. Now, moving on to domain of g. We have a fraction, so we just need to make sure that the thing in the denominator is different from 0, because you cannot divide by 0, okay? So, oops, I want it white. Okay, so x squared minus 1 needs to be different from 0. And now this is a super recognizable and important formula. That's the, what was it called in English? Difference of squares, I believe. 1 square minus another square, because 1 can be represented as 1 squared. I hope you remember that, because it's a high school formula basically. And you have x minus 1 times x plus 1, right? Or let me just give a couple more examples. If you had x squared minus 4, then this is the same as x squared minus 2 squared, which in turn is x minus 2 times x plus 2, right? So the first time you just take the original expression but without the second exponent, and then you multiply by the same thing but with the plus, okay? That's the difference of squares formula. Sorry if you already know it and you're finding this boring, but I know that some things are easy to forget, so I just wanted to remind you of that. This is like one of the most essential formulas you have to use in your calculus quizzes and exams. Okay, so that expression has to be different from 0. Okay, good stuff. Therefore, you just need to find the roots, right? So if, from here, if x is 1, then that's a problem because the expression will be 0. Therefore, we need the x to be different from 1, right? Now, let me just explain again. If x was 1, this would give us 0. 0 times whatever is 0. But we wanted the expression to be different from 0. Therefore, we insist on x being different from 1. And from the second portion, it follows that x also needs to be different from minus 1. Because minus 1 will trigger a 0, but we don't want a 0. All right, so these are our excluded values, and everything else is within the domain of G. So the domain of G, you could write in a couple of different ways, domain of G. One option, which is the easier one, is to write R, which is like all real values, without or except or minus 1 and 1. Minus 1 and 1 are not in the domain. By the way, students very often ask me, when do I write, these brackets or like these? And when do I write curly braces? Okay, so curly braces I write only when I want to mention two specific values, right? In this case, we're just excluding -1 and 1, but not the whole range between them, right? So the regular, they're called parentheses, we use when we have all values between the minimum and the maximum. In this case, these are not minimum and maximum. These are only two specific values that I'm excluding from the domain. So that's one notation you could use. The other one is through the whole range. So if we were to draw this on the number line, -1 and 1, we basically have everything except for -1 and except for 1. So if I were to write it down, it would be -infinity to -1 in union with -1 to 1. We just need to make sure we're not including the -1 and 1s, right? That's why I'm using these arc-like parentheses. Union with 1 to plus infinity. Basically everything except for these two values, okay? Cool stuff. Now we're left to find the domain of f. Sorry, not f, but h. That one's going to be decently easy, I believe. So again, we have an even radical. So what do we need for an even radical? We need the quantity inside of it to be greater than or equal to 0, right? So we're going to have 25 minus x squared greater than or equal to 0. That's, again, the difference of squares. That's 5 squared minus x squared greater than or equal to 0. I can use the formula now that I showed you earlier. This is going to be 5 minus x, right? I just take the original expression without the exponents. And then I multiply by the same thing, but with a plus. So 5 plus x greater than or equal to 0. Now I'm going to draw my number line. Obviously from here the roots are going to be -5 and 5. So for this case it's going to be 5. For the other one it's going to be -5. But now notice that previously we just needed this to be different from 0. However, now we have a stricter thing. Now we need it to be greater than or equal to 0. So how do we find it? Well, obviously, these two numbers split the number line into 3 intervals, right? First interval, second interval, third interval. So we need to check what the signs will be within each interval, okay? I can actually split it this way. But now I don't really know the signs. And as I've showed you previously, the way I do it is I just pick a random number in between these two, for example. Let's say between -5 and 5, it's easiest to select 0. And then I just plug it into the original equation and I check if I receive a positive or negative number. Okay, so if I plug in 0, I'm gonna have 5 minus 0 times 5 plus 0, which is gonna be 5 times 5, which is 25, and it's greater than 0. So this whole range here between -5 and 5 is gonna be positive, okay? And then most of the time, these are alternating, so I can assume that the ranges on the left and the right are going to have a minus sign. But on the test, I recommend that you still test it. So you just pick a random value in the third interval. So it needs to be from 5 onwards. Let's say, I don't know, just 6. And then we're going to have 5 minus 6 times 5 plus 6, which is -1 times 11, which is -11, and it's negative. So my assumption that the sign is going to be a minus was correct. And then you can do the same for that last interval. You just pick, for example, -6, you plug it into the equation and you check the sign, right? I'm not going to do it now, but I already showed you with 2 examples, so I hope it's clear. Okay, we're done with the separate function domain. Oh no, actually I haven't written this down explicitly, right? So I was wondering, for which values of x do I get this to be greater than or equal to 0? Well, it's greater than or equal to 0 in this range, right? Here we have a positive sign. So the domain of h goes from -5 to 5. Okay, that's the thing. Okay, so far so good. From now on, it's actually going to get easier. Okay? Once we have these figured out, it's kind of easy to just combine them in different ways. All right, can I? Okay, I'll just switch to a new page. So our first task for part A is to find f plus g plus h and the domain. So f plus g plus h is just the sum of the three functions. You know what? I'll just copy this so that I have it on the other page as well. Copy. Okay, I'll bring this down. Come on, bro. My pen suddenly decided to stop working. Okay, thank you. So I just paste it here so that it's easier to copy things. All right. So whenever you're asked to find the sum, you just literally copy this and you write plus, and then copy this and you write plus, and then you copy this. And most of the time you aren't even required to do any simplification. So it's super easy to do, right? Please don't lose points on that. You can just do it. 4 minus x, I just copy the function and then I write plus, and then I copy the second function, which is 1 over x squared minus 1, plus, and then I copy the third function, which is 4th root of 25 minus x squared. And I leave it at that. I don't need to do any further simplification or anything. Now for the domain of the sum, what was the rule? Well, it's just the intersection of the three separate domains, right? So I had written it somewhere here. It's just gonna be the intersection. In this case, we have the sum of all three functions, so it's going to be the intersection of all three domains. But that's not really hard to do, because you already have the domains. So I'm just going to draw them on the numerical line, and we're going to find out what the final intersection is. So for f of h, we needed x to be less than or equal to 4. So I'm just going to draw 4 somewhere randomly. And I'm just going to pick some color. We need the x to be less than or equal to 4. Okay? Like that. All right. Then for g, we had all values, or real values, except for minus 1 and 1. So I'll now draw minus 1 and 1 somewhere. And I'm just gonna exclude them from the domain. So there's two ways. In the Bulgarian educational system, they teach us to put like an empty circle. In the American system, I think they just draw this in order to point that it's excluded. It doesn't really matter which notation you use as long as you understand it, right? So we exclude these values. And then lastly, for the domain of h, it's between minus 5 and 5. So I'm gonna draw minus 5 and 5, and I connect them like that. Okay? Wait, let me just draw it. Oh, no. I want to draw it slightly better so that it's more readable. Like this, okay? And now, what is our task? Our task is to see where all three of these overlap. So the yellow is basically everything except for these two values, right? So the yellow is the biggest range. Green and red need to intersect. So where do they intersect? They start intersecting, oops, come on. They start intersecting here, right? Because on the left, we only have green, but no red. We keep going. We exclude the yellow minus 1. We keep going, because here, as you can see, there's still, we have both green and yellow, green and red, and of course yellow. We keep going, and here we need to be careful. We should stop at 4 because we don't have the green up after 4, okay? So that's the intersection of these three. Again, yellow runs through the entire thing except for the minus 1 and 1. I just didn't fully draw it, but I guess you can get the hang of it. Okay, therefore, the domain is going to be that white thing that I just drew. So it's going to be minus 5 up to minus 1, but minus 1 we need to exclude. So I'm closing the bracket like this. Union with minus 1 to 1. Union with 1 to 4 inclusive, because I have a sharp edge here, right? The 4 is included. Okay? So that's our first domain for f plus g plus h. Okay, let's move on to the domain of f dot product h. So part B is domain of f dot product h. Oops, h. Okay, let's first just multiply the two functions. Again, super easy, don't lose points on that. You just copy the first function, which is like square root of 4 minus x, and then you just literally write the multiplication sign, and then you just write the second function. H is fourth root of 25 minus x squared. 25 minus x squared, okay? All right, good stuff. And you don't need to do anything further, okay? Just leave it at that and you get the points. Now, the domain is same thing. You just find the intersection of the separate domains of f and g, okay? So that's domain of f intersected with domain of h, in this case, not g. So I'm just going to draw the number line again. F is minus infinity to 4, right? So I draw, come on, bro. I draw the 4, and I have, what color did I use before? Okay, like that. And then H was minus 5 to 5, I believe. Yeah, H is minus 5 to 5, okay? And now I just track where the two overlap. So where I have both green and red. So both green and red I have starting here up to the 4. So that would be domain of f dot product h is minus 5 up to 4 included. Okay? All right, good stuff. And point number C, let's check it out. So for C, we need to find the domain of g divided by f. Okay, that's interesting. So firstly, let's just calculate the function itself. G divided by f. So g is 1 over x squared minus 1. And that entire thing I need to divide by f, which is square root of 4 minus x. Square root of 4 minus x. Now here, I guess the only simplification I would do, but you don't even have to, is I would just rewrite this as 1 over x squared minus 1. And you know how whenever you have a fraction divided by something, it's the same as multiplying by the reciprocal of this, which would be 1 over square root of 4 minus x. And then I can just combine, and it's going to be 1 over x squared minus 1 times square root of 4 minus x, like that. But you don't even have to do this. I just get annoyed by like composite fractions, so that's why I simplified it, but you don't have to do it, right? And the domain of g over f. Now, it's almost the same as in the previous cases, right? We start with the intersection of the two, okay? But because the denominator cannot be 0, from this intersection, I'm going to exclude the points where f equals 0. I don't want f to equal 0 because we'll have 0 in the denominator, and that's a problem, okay? So that's the thing. And from here, I'm just going to draw things again. So domain of g is everything except for minus 1 and 1. Minus 1, actually, that's going to be 1 minus 1. Everything except for these two. So literally like everything else is yellow, okay? I'm gonna erase it now, but just imagine that everything is yellow. All right, then domain of f was 4. So from minus infinity to 4, like this. So the intersection is literally everything except for minus 1 and 1. But from that whole thing, we need to exclude the values where f equals 0. Now, f is equal to that thing. When would that thing equal 0? Well, it would equal 0 if the portion inside of it is 0. And when is 4 minus x equal to 0? When minus x is equal to minus 4, therefore x is 4. That's the only problematic value. That's the value for which f equals 0. But then if it's in the denominator, it's going to be a problem because we cannot divide by 0. Therefore, from my range, I'm just going to exclude the 4 as well. Okay? Or in other notation, I could just change the angle here. It's not going to be sharp anymore. It's going to be an arc, meaning we're not including the 4. We're going very close to 4, everything in between, but not including the 4. Okay? Therefore, the domain here, domain of G over F would be minus infinity to minus 1, because we need to exclude the minus 1, union with minus 1 to 1, union with 1 to 4. The only difference is this time I'm not going to have this parentheses, because this means that we're including the 4, but I want to exclude the 4, therefore I'm going to use the regular parentheses. And that's the final answer. So this is our final domain for part C, this is for part B, and this one is for part A. By the way, I'm explaining in a lot of detail, but keep in mind that on the test, if you're just doing the solutions without explanations, it's actually gonna take like a short period of time. You could do it within like 5 minutes or so. So yeah, I would advise you to like learn how to do this one, because I think it's one of the easier problems, and I'm sure you can get the hang of it. And it's basically 2 main rules. Even radicals need to have an expression that's greater than or equal to 0, and fractions need to have a denominator that's different from 0. That's it. And from there, you just need to be careful with the calculations.